We are on Chapter 7, Test Review. This test review will get you good and ready for our test. So make sure that you understand every one of these questions. If you don't, make sure you email me or come in early on Wednesday. Number 1, we have 112 students in the marching band. 35 are in the drum section. So that means that there are some students that are in band, but not necessarily in percussion. We want to know the ratio of drummers to other musicians. So how many people play something other than drums? Well, we have to figure that out by doing 112 minus 35. That gives us 77 people who are in band but not in the drum section. We want to know the ratio of drummers to other musicians. So how many drummers were there? There were 35. How many other musicians? There were 77. And as with any ratio, make sure you reduce that. Both can be reduced by 7. So our ratio is 5 to 11. Number 2, we want to know whether or not these quadrilaterals are similar. So one thing is we have to match up our angles, find our corresponding angles. So let's start with this right angle, angle C. Its corresponding right angle is angle H. Then let's go to angle B, and its corresponding angle is angle F. Angle D has 2 lines. Its corresponding angle is angle G. And lastly, angle A corresponds to angle E. So all of our angles are matched up. Now to make sure that they are similar, we have to check and make sure sides are proportional. So let's take this side right here, BC. It has one arc and the right angle, BC. And you can see in our list, BC, they're right next to each other. That side should correspond to the side HF if this were similar. So BC is 9, and HF, if I look on my quadrilateral, there is no side HF. They are opposite to each other. So if there is no side HF, then these cannot be similar because we cannot prove that the sides are proportional. They're not going to be. So our answer is no. The sides are not proportional. Number 3. Number 3 is best solved by sort of drawing it out. If I have a 9-foot tall garden and its shadow is 5 feet 3 inches, then I also have a house which is going to be much taller than 9 feet. I don't know how tall it is though, so I'm going to give it an X. And its shadow is 28 feet. To find the height of the house, I should see that I have similar figures here. I can solve for the house by setting up a proportion. Now the only thing you have to be careful of is this shadow right here. It's got feet and inches. That's going to be a problem. You cannot write it as 5.3. We have to figure out what fraction of a foot 3 inches is. So let's change this to 5 feet and then 3 inches out of 12 because there's 12 inches in a foot. We can reduce that to become 5 1/4 feet. Okay, that's going to be a whole lot easier to solve in our proportion. So let's set up our proportion. We're going to do 9 over, I'm going to change this to a decimal, 5.25. And then my corresponding side for the house is the side here, or the height that I don't know, over the shadow, 28. Let's cross multiply. 9 times 28 is 252. And then let's divide by 5.25. And we get the house to be 48 what? Tacos? Although that sounds good, that's not how tall the house is. 48 feet. Okay, turn the page over to number 4. Here we're told that we have two similar triangles, but there's no picture. You want to find the scale factor, which is a ratio of two of your sides. Now, because there's a lot of numbers given to you, I highly recommend you actually drawing out what your shape is going to look like. It doesn't have to be exact. You know it's a triangle, and you know one of them is labeled ABC, and you know you have another triangle, and you know it is labeled FGH, and then you could just label your sides. AB is 24, AC is 16, GH is 9, and FH is 12. To find the scale factor from of ABC to FGH, first thing you want to know is, did the side measurements go big to small, or did it go from small to big? What happened from this original triangle to the second triangle? Yeah, it got smaller. So our scale factor should be less than 1 because our original shape is bigger than our other shape. So we actually want to put FGH on top because it has a smaller side. So the only two sides I know that correspond are those two, FH and AC. So let's put those on as a ratio. 12 to 16. So I should probably reduce it. And that's my scale factor. That means that triangle FGH is 3/4 the size of triangle ABC, which makes sense. It's a little bit smaller. Number 5. You've got a suspension bridge. And again, if you want to draw it out, draw it out. I've got a model bridge, and my model is 18 inches long and 2 inches tall. And I'm comparing it to the actual bridge, which of course is going to be much bigger, and it is 1,650 feet long, and we don't know how tall it is. But to find out how tall, we can make a proportion. So let's do 2 over 18, and we're going to set that equal to x over 1650. Cross multiply. And then let's divide by 18. Now when you go to divide in your calculator, you will notice that your answer, your decimal part, goes on forever. So instead of rounding it, because it does not ask you to round it, you need to remember what fraction that is. So your answer, the accurate answer, is 183 1/3 feet. That is how tall the bridge is. Okay, number 6. We want to find GP. We don't know it, so I'm going to label it X. We can make a proportion. We have a theorem that states that these sides are proportional. So 4.5 over X equals 2.7 over 3.3. To solve for X, let's cross multiply. 4.5 times 3.3 is 14.85. And divide by 2.7. The length of GP is 5.5. Excellent. Number 7. Okay, I know that these two triangles are similar because it tells me right there by that symbol. So to find the value of X, I need to set up a proportion. This whole chapter is about proportions. So XJK corresponds to this side, PQ. So X over 6 equals 35 over 14. Now remember, with a proportion, you can set it up X over 35 equals 6 over 14. That's okay. There are 3 different correct ways to set up a proportion. So if you set this up a little bit differently, it's okay. You will still get the same answer if it is set up correctly. So let's cross multiply. And 35 times 6 is 210. Divide by 14. And X is 15, which is the length of JK. Okay, number 8. This is a little difficult to see, and I'm sorry, but first of all, we know that it's a dilation. We know that it is an enlargement from A to B, because B is bigger. But we want to know if it's a similarity transformation. That means that our sides have to be proportional, the length of our sides. Since these are both right triangles, we are going to compare the ratio of the length of the legs here. So let's look at our triangle A in this bottom leg. This length, it is 3 units long, and the length of the bottom leg of the bigger triangle, triangle B, is 8 units. We want to see, is it proportional to these legs? So this leg on triangle A, it is 4 units, and the length of the bigger triangle, triangle B, it is 8 units. So right away you should be able to tell, does 3/8 equal 4/8? Are those the same? No. Since these ratios are not the same, our sides are not proportional. So that's how we're going to verify. Since it is not proportional, It is not a similarity transformation. And there's our proof. Not equal. Number 9. Here's another one where it might be best for you to draw it. So I'm going to draw out ABC. And it tells me AB is 18, BC is 20, and AC is 22. Then I am going to draw PQR. And it only tells me QR, that it is 25. I need to know the perimeter of this triangle. Now, there are two ways you could do this. One way is you could set up proportions and find these missing side lengths, or you could use the scale factor and use the perimeter of this. I'm going to do the second one since that one is probably the one that most people will not know how to do. Either way, you will get the same answer for the perimeter. So first of all, I need to know what my scale factor is. And remember, scale factor is a ratio. And so from ABC to PQR, I should notice it got bigger. So I want the bigger number on top. If I reduce that, my scale factor is 5/4. This triangle is 5/4 as large. Okay? That means the perimeter of this is going to be 5/4 as large. So what's the perimeter of ABC? Well, add up all of our sides. 18 plus 20 plus 22, and you get 60. The perimeter of PQR is going to be 5/4 that size. So I can take 5/4 and multiply it by 60. And that gets me 75. Number 10. I want to identify the similar triangles. So what you want to do is be very careful as to the order. So I see a little triangle and I see a big triangle. So if I start with the little triangle, I'm going to start right here. X, N, M. Now, I started with X because X is also a part of this big triangle. So if you remember, X has to be congruent to itself. So X has to come first in this next triangle. So then you want to look at, okay, N. If I look at angle N, there was a right angle. On my big triangle, I have to have a right angle, and that's Y. So, X, Y, and then Z. Not always is it going to be in alphabetical order. So be careful when you're listing your letters. Okay, number 11, I want to find NM. So if I think about MN, MN is this side right here. Okay, NM. It corresponds to YZ. How long is YZ? It's 20. So there's my first ratio. And then I'm going to pick the other side that I know. I know XN, which is 6. And it corresponds to XY, which thankfully they gave us, is 16. Alright, now I can cross multiply and solve for x. 16x equals 120. Divide by 16, and I will see x is 7.5. Awesome. Okay, number 12. I know that these shapes are similar, so I'm probably going to set up a proportion. I am going to set up 4.8. It corresponds to 16.8. And I have a theorem that says if I have medians, they are proportions. So this median right here, AF, that's going to go on the bottom. And this median right here, BL, that is going on the top. Let's cross multiply. And go ahead and divide by 16.8. And you will get x equals, or BL, 2.2. Awesome, we're about halfway through. Okay, number 13. The ratio of the measures of 3 angles of a triangle. Remember, this is the one where you have to remember how many degrees are in a triangle. So let's make an equation. 3x plus 4x plus 8x, all of those angles have to add up to 180. Let's figure out what x is first before we figure out the largest angle. So let's add all our x's, and we get 15x. And then let's find out what x is. Okay, so x is 12. Is that the measure of the largest angle? Not quite. The largest angle is this right here, 8x. So I need to plug in what x is. So let's do 8 times 12, and we get 96. 96 degrees is our largest angle. Okay, number 14, we want to find angle y, right here. I have no degrees on that quadrilateral, so how in the world am I going to figure that out? Well, I have to notice that these are similar, and I have to look up here. Angle y is right there, the third letter. So I need to come over here and see what angle it corresponds to, and it corresponds to angle F. And when your shapes are similar, it means that your angles are congruent. So if angle F is going to be the same, angle Y is going to equal 85 degrees also. Number 15. Here we've got a little bit of algebra mixed in with our proportion. So let's set it up. Remember, these sides correspond because of the bisector theorem. So 40 over 3x minus 1 equals 32 over 2x plus 3. Cross multiply, and don't forget you have to put these in parentheses. So you will get 40, 2x plus 3 equals 32, 3x minus 1. You have to distribute both of these numbers before you can solve for x. So let's go ahead and do that. 80x plus 120 equals 96x minus 32. Now I can do some algebra and solve for x. Minus 80x and then add 32. And then divide by 16. And you will find x equals 9.5 or 9.5. Perfect. Alright, number 16. I want to find the value of x so that these are parallel. In order for them to be parallel, their parts have to be proportional. So 2x minus 1 over 3 3. 2x minus 1 over 3 equals 3x over 6. Again, cross multiply, make sure 2x minus 1 is in parentheses. Okay, let's distribute. That's 6. 12x minus 6 equals 9x. Let's take 12x to the other side. Negative 6 equals negative 3x. So when we divide by negative 3, we find that x equals 2. Is that what we wanted to know? Yes, we just wanted to know the value of x. Okay, number 17. More similar triangles. You will be experts by the end of this of similar triangles. I want to find gx. I don't know it, so I'm going to give it a variable. Again, let's make a proportion. 27 over 12 GHKL over or equals x over. I'm going to change this 2.5 to a decimal to 2.5. Okay, cross multiply. 27 times 2.5 is 67.5. And now I'm going to divide by 12. And again, you're going to get an ugly decimal. So you may want to change it back to a fraction. And especially since you're given a fraction in the problem. So x equals 5 and 5/8. Whew, 2 more. Number 18. Find the value of x. So remember, one of our theorems was about parallel lines. When you have parallel lines, it also creates proportions. So I'm going to find y by setting up a proportion, just like I did in the last example. 42 over 12 equals 2y over 16. Cross multiply. 672 equals 24y. Let's divide by 24. And we will find that y equals 28. Okay, the bonus. Find FG. So this figure's a little complicated. You'll notice that AB is parallel to DF, and BD is parallel to GF. I want to find FG, which is over here. So what I can do is I can see that 2.8 corresponds to 4.2. And 3.2 corresponds to X. I'm going to let you solve that on your own, and we'll talk about what the answer is in class. So remember, this whole chapter, you should remember one word: proportion, 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 proportion. And I'll see you for Chapter 7 test.